So hello everyone and welcome to the beginning of this video lecture series on power electronics. So I'll be starting with simulating several DC to DC converters. So I will start with the simplest converter, which is the buck converter. So before I get started, I will just go and launch my circuit simulator. So as before, just use any terminal. I'm using GNOME terminal because I'm on Linux and using GNOME. So first I will activate my environment. So before I do that, I can just list out my environments. And I've created CircuitSim, which will be the environment that I'll be using. So I'm just going to activate it, and you see CircuitSim appears in brackets here, which means that it has been activated. So now that I'm in here, I just will go over to my directory. I just have to change directory until I reach the file manage.py. This is the file which launches this circuit simulator. And I just run this command, python manage.py run server. So this should launch the circuit simulator, which it does. So all I have to do is copy this link, and I will just go over to a web browser like my Google Chrome and I'll paste it there. So this starts my circuit simulator. So now the circuit simulation library is empty because we are just starting with this project. I will create a new simulation to begin with. So let me go and click on this create simulation. This starts this new form. I'll just zoom in a bit. Okay, that makes it a little more clear. So let's give in some values. So the simulation title here will be buck converter because that is what I'm simulating. And let's just copy this here. You could give a more descriptive title, description here. It's alright. Time duration for now 1 second is good enough. Integration time step can remain 1 microsecond. The time step of data storage can be 10 microsecond. We can actually reduce this to 1 microsecond as well. So both the integration and the time step of data storage are the same. The output data file can remain as it is. There is no need to slice the output file, at least not now, and the number of slices doesn't matter because we are not slicing the output file. So now that we come to the last parameter, that is directory with circuit files, let's go and create a new simulation. So I created this directory called simulations where I'll be storing all my simulations. So let's create a new folder and let's call this buck converter. So inside this buck converter, I'm going to start my simulation. So first and foremost, let me go and create a circuit. Now this circuit is that of a buck converter. Let me just zoom in a bit. So a buck converter is basically a voltage source. And let's call this Vin because it's the input voltage source. And this is connected to the switch, which we'll just call S1 for now. And let's connect S1 to inductor L1 and inductor L1 in turn will be connected to resistor. Finally, we reach the output. So the output will contain of three parallel paths. One is the capacitor. Let's call this C out. The next will be the actual resistive load. So let's call this resistor load. and the last will be the voltmeter, the measurement of the voltage. With this, let's complete the circuit below. So here we need to make another change, and that is we need to add the diode. And a couple of other small changes. In this circuit, we will need, the capacitor needs a parasitic resistor because you cannot have a pure capacitor as a branch. So let's call this also RC out. And we need to measure some currents. So let's call this ammeter input. And we'll call this ammeter L1 because it measures the current through the inductor. Ammeter D1 measures the current through the diode. Ammeter C out measures the current through the capacitor. And ammeter load measures the current through the load. So let's save this in the buck converter directory. And here we choose the format to be CSV. It'll ask me this question because we are not saving it in the default format. That's okay. And it's important to note that the field delimiter should be a comma, and the text delimiter can be either a double quote or a single quote. That's okay. But do not use a semicolon, a colon, tab or space. Do not use these. Make sure that the field limiter is a comma. So with this, let's close it once and let's open it again. Make sure that it's opened. So we managed to open it. So that's okay. So now that we've done this, let's add this to the simulation, or rather we need to add the directory to the simulation. So for that, we just go right click on it, go to the properties, and here you'll see the parent folder. So we just have to copy this. And we will paste the directory here. So this becomes our working directory of the simulation. Right? So this is where we'll store all our circuit files, and this is where it will also store the output data file, and also when we plot files we'll find that the image files are saved in the same working directory. So now that we've done this, we are ready to save the simulation parameters, and we can do so. So since it has saved successfully, it means that the simulation parameters are acceptable. If there was an error, it would have pointed out those errors. So the next step is we add a circuit file. And here we have only one circuit file, so all we have to do is click on the CSV file that we just created. Let's call this buck converter, and we save the file. So the file has been saved because it appears in this list. When we add a file, we have to press process circuit schematics, because this will process the circuit and make sure that there are no errors. If there are errors, it will point out their errors. For example, this message here says the circuit does not have any detectable errors. You can continue to enter the parameters by clicking on the back to main page. So the circuit that we have created is acceptable. And As you can see, this is indeed a buck converter, so we are now ready to simulate a buck converter. So let's go back to the main page and let's edit the circuit parameters. So you see the view components comes up, and there's this only one file, buckconverter.csc, because we have only created one file. So here we can actually just go and edit the circuit parameters. So the first one is the ammeter Cout. So the ammeter Cout is all the way here. You see that it is in position 11O. Now the current through the capacitor is going to flow downwards because this is a DC to DC converter, and the positive direction of voltage is going to be upwards, so therefore the current will be downwards. So since the component is in position 11O, let the positive direction of current be 12O. So let's go and change this. So it is currently at 10O, which means it's pointing upwards, but it should be pointing downwards, so we just make that change. The next is the diode. Again, the diode is here. This is the diode current ammeter D1. It is at position 5F. Now here the diode current actually flows upwards because the diode is a freewheel diode and the current through the inductor flows towards the right, so therefore the diode current will flow upwards. So here the current can actually stay as it is because the component position is at 5F and the direction, positive direction of current is 4F, which means it's upward, so it can stay as it is. Now let's look at the next one, that is inductor L1, ammeter L1. So ammeter L1 is at position 1H and the positive direction is at 1G. So let's go over here. You see the positive direction is 1G, which means it is considering the positive current as flowing towards the left. Now actually this would not really be right because in this case the positive direction of current flows towards the right. So therefore let's make this change. And here we have to change this to 1I. And the current, the input current that is here is 1A. The current will flow towards the right because the input is providing energy to the output. So therefore the positive direction of current should be 1B, which is what it is. So we can leave it as it is. The last is the ammeter through the load. This is the ammeter through the load. It is at position 5Q. Again, the positive direction is at position towards 4Q, which means it is upwards. But actually, since this is a DC-DC converter and the positive direction, positive voltage is upwards, the current will flow downwards. So therefore, let's change this to 6Q. That means downwards. So let's edit. And let's click on 6Q. With this we are downwards. So the capacitor Cout has a value of 10 microfarad, right? Now of course we could start at 10 microfarad, but 10 microfarad is pretty low. The output DC capacitor should be a little higher, so let's increase this to 500 microfarad. The positive polarity is 7O. Now again, the polarity of a capacitor doesn't really matter, it's mainly for debugging purposes, but even then, let's go over and check to the circuit schematic. This is the capacitor at position 8O. The positive polarity is indeed upwards because we will be using, in practice this would be an electrolytic capacitor, and the positive polarity will be upwards because the DC-DC converter will have the positive DC bus to be the upper bus. So therefore this can remain as it is. We don't have to change this positive polarity. So let's save the parameters. And this brings us to the diode. The diode is at position 8F with the positive, with the direction of cathode is 7F. So let's go over. So this is the position of the diode, which is at 8F, and the positive direction of the cathode, or rather the direction of the cathode, is at 7F, which means the diode is pointing upwards. Now this is indeed how a diode buck converter is, because a buck converter, this diode acts as the freewheel diode, which means it lets the current through the inductor freewheel, and for that the cathode has to point upwards and the direction of the diode has to be upwards. So therefore this parameter is indeed okay. What however needs to change is the voltage level, right? So let's go and change the voltage level and make it a little higher. So let's make this 1000 volts. Now the next one is the inductor. The inductor, let's start initially at 1 millihenry. We can edit this later, but let's start at 1 millihenry. The resistor of the capacitor. Now the resistor of the capacitor, C out, is this one at 5 ohm. This is a parasitic resistance just to make sure that this branch does not have a zero resistance. In the circuit simulator, no branch must have a zero resistance. So all we need to do is add a very small resistance. 100 ohms is way too large. So let's edit this. And finally we come to the resistor L1. Also the resistor L1 is a parasitic resistor. This represents the loss of the inductor, or rather this resistor R1 is the loss, basically is the loss of the inductor. So it can be also a very small resistance, does not have to be 100 ohm. So I'll choose it to be 0.1 ohm. And finally we come across the switch resistor. The resistor of the load can be set to be around, let's say, 10 ohms, right? We just choose any value for now, it doesn't matter, it can be high, it can be low. Let's start with the value of around 10 ohms for now. We come to the switch. Now the switch is at position 1D, and the negative polar terminal of the switch, or the cathode, is towards the right, because the current through the switch will flow from the left to the right. So therefore the negative, or the cathode, should be pointing towards 1E. So let's go over and you see that is indeed the case. So we don't have to change the direction of the cathode. What we do need to change, however, is the voltage level and the control tag. So let's go over and change that. So let's make the rated voltage level to be the same as the rated voltage level of the diode. And the negative polarity can say the same. The control tag is basically a unique name given to the control tag of the switch, right? This is mainly in order to be able to identify every controllable component specifically later for debugging and other purposes. So let's call this switch S1. Let's give it the same name as the component name because that's usually unique. And finally we come to the voltage source. The voltage source should be a DC voltage. So first and foremost, let's make the peak 0. The frequency doesn't matter, but let's make it 0 anyway. The phase angle also doesn't matter. What matters, however, is the DC offset. So now the DC offset, let's consider a 24 volt DC battery, right? So we want to step this 24 volts down to say 12 volts. That's our purpose. Okay. So the positive polarity, the component position is at 8A. So let's go over to the circuit schematic. The component position is at 8A, and the positive polarity is 7A, which means the positive polarity is upwards, and that's perfectly okay. That's what we want. So we can leave that as it is. So with this we can save the parameter of the voltage source. And finally it's the voltmeter. Here we need to choose, again there is a component polarity of 8S. So let's go over to the circuit schematic. Let's check out the voltmeter. The voltmeter is all the way towards the right. Now 8S is here, and the positive direction of voltage is 7S, which means anything, that means this 7S is upwards. The voltmeter will consider all voltages on the upper terminal to be positive, and that's exactly what we want. So we can leave that as it is. All we have to do is increase the rated voltage to be the same as that of the diode and the switch. So with that, we can save these parameters. And we have made the first basic changes to the circuit simulator parameters. Now the next part will be, we have to edit the control. Here it will be a little more complicated, so I'm going to stop this lecture now, and I will continue this in another lecture where we will exclusively talk about the control in the DC-DC converter. But before that, we might run the circuit just once, just to get an idea of what happens. So anyway, thank you so much. If you have any doubts, please do post, please do feel free to comment on this video. Otherwise, I will see you in the next lecture. Thank you so much, and goodbye for now.